stopwatch resolution and uncertainty. Let's do this practice to understand this concept. How long would you take to toss and flip a coin? To do that, use your cell phone stopwatch. Do you see 00.00 seconds? It's because you have a digital display. So the resolution of this stopwatch is 00.01 seconds. So that's the smallest increment the stopwatch is going to count. To practice this experiment, you hold a penny or any coin and press start on your stopwatch. Throw the coin upward, you are tossing, grab it and land on the back of your head. And then you stop the stopwatch and you record your first trial in the box below. This table shows the result of my trials. Notice that I'm using 2 decimal places for all of them. You have to have a consistency with the decimal places. Now I look my sample here and I notice this number is a little bit above of the other ones. So if the idea is to eliminate errors in my measurement, if I include this number in my computation, I'm actually adding error. So I'm going to go ahead and eliminate this trial. So following the script of this lesson, if you have one of your trials that is not consistent with the others, like way above or way below compared to the other numbers, so mark with an X to eliminate from your computation. In this case, you'd have just 4 trials left. Now, if you want to keep all your numbers, if they are all consistent, so you have to do your computation with 5 trials. In my case, I'm eliminate this, so I'm gonna use just 4. So now I'm going to add all my trials and divide it by the number of trials, which is 4. So my result is 2.8575 seconds. However, since I'm using all 2 decimal places, my mean average, which is this number, also need to have 2 decimal places. So in this case, I'm going to round for 2.80. Now this is 7, so I'm going to round this to 6. So this is my mean average. Next, I'm going to calculate the uncertainty. In this case, I'm going to select the greatest value of my trial minus the lowest value of my trial and divide by 2. This is the uncertainty. So here is uncertainty is my biggest value here is 3.09 minus my lowest one is 2.76. Remember that I eliminate these, so I don't use in my computation all these divided by 2. So this is the result of my uncertainty. And again, because I can use just 2 decimals, I need to round this number. So it will be 1.7 seconds. Now remember, the uncertainty is written by plus minus and the value of my uncertainty, which is 1.7 seconds. Now finally, I'm going to write my mean value, which is this, with its uncertainty on this line. So I'm gonna write down here so we don't get kind of blend of numbers. So my mean value is 2.86 plus minus 1.7 seconds. Notice that the unit for time is second. I'm using just for the uncertainty. Now let's review or learn what is parallax error. Parallax error got to do with your eyesight, how you are reading your measurement. In this case, I have this wood rod that is placed by this ruler, but if I have my eyesight in this direction, I'm going to read 21 millimeter because that's the unit that I'm reading. If I have my eyesight aligned with the measurement, so now I have 21, 22, 23 millimeter. And if I'm looking this way, so now I'm going to read 21, 22, 23, 24, 25 millimeter. So here I have 3 different values, but the correct one is the one that you align with the measurement. Now let's do some practice problems. Problem 1. This picture indicates 2 rulers with different scales or resolution. What is the resolution of each ruler in centimeter? So this first ruler is the standard ruler, which means that is the correct one that you are going to base in order to determine the resolution of the second ruler. So for this ruler, as you see, the smallest increment of this ruler is 1 millimeter. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can write the smallest resolution is 1 millimeter. But because the problem is asking in centimeter, so that is 0.1 centimeter. You may think, how did I get 0.1 centimeters? Okay, remember that 1 centimeter, we have 10 lines. Each line is 1 millimeter. So 10 millimeter, which means that 1 millimeter corresponds to 1/10 of centimeter. So we are not using this fraction here. So this fraction can be translated into decimal, which is 0.1 centimeter. To determine the resolution of the second ruler, we are going to place this ruler right here, and this is my first mark, and this actually corresponds to 2 millimeter. If I do some close-up, you can see very clear that we have 2 millimeter on this standard ruler, and on this one you have this mark corresponds to 2 millimeter or 2 lines right here. So the resolution of the second ruler is 2 millimeter or 0.2 centimeter. Problem number 2. 5-time trials in seconds were taken during an experiment. Calculate the mean value for time and its uncertainty. Our first observation is that they are all at the same range, but this one here. So we are going to eliminate this trial that is kind off, so we don't add more error. We are trying to minimize error. So as you do that, now we have just 1, 2, 3, 4 trials left. So I add all the trials and I divide by the number of trials. Since I eliminate 1, now I have just 4 left. So this is my result. Because all they are with 2 significant figures, so this result must be also in 2 significant figures. So here will be 3.61, because this is 2, so I will keep like that. So 3.61 seconds. To calculate the uncertainty, I'm gonna use the largest number of my trial, which is 3.64. minus the lowest number of my trial, which is 3.58 divided by 2. So my result is 0.03, and I do not have to make any adjustment about the decimal places. As the final result is the mean value, 3.61, plus minus the uncertainty, which is 0.03 seconds. Last problem. A length is measured 5 times with a ruler whose smallest division is 0.1 centimeter. And the readings obtained in centimeter are 22.9, 22.7, 22.39, 23.0, 23.1. What is the reading obtained and the uncertainty? What this problem is looking for here is the mean value and the uncertainty. 2 observations. 1. When I look at this set of numbers, they are all consistent. They are all at the same range. I'm not going to eliminate any. The second observation is about the decimal places. So here we have 1 and here we have 2, and the rest we have 1. So I'm going to present this result with 2 decimal places. So here I'm showing the addition of all my trials, and I have highlighted the correction that I did for the decimal places. I want all with 2 decimal places. And when I add all divided by 5 trials, because I did not eliminate any, my result is 22.818. So I'm going to round this 8. So see, this is 1, and I'm going to round the 1 to 9. So that is my mean value. To calculate the uncertainty, so I subtract the greatest value of my trials, which is 23.1, minus the lowest reading, which is 22.39, divided by 2. So when I divide, I have this value right here. So now what I need to do, since I'm using just 2 decimal places, so I'm gonna round this number to 0.36 seconds. The final answer, the mean value and the uncertainty must be combined in the same answer, is 22.89 plus minus 0.36 seconds. Notice that the unit go with the uncertainty.